Hi, my name is Fabrice Trollet and I am the MaTeLo Product Manager at All4Tech. Welcome to this MaTeLo tutorial session 6. You are going to learn how to generate your scripts with test benches, robots or datasets. Let's see how you can automatically generate test scripts which can be executed on your test bench. Go to the Test Platform tab. MaTeLo is able to generate an important number of test script formats, test binary files, test.sec files, or connection to databases allowing to remotely execute test cases, for example exam, which is an automotive test bench. You can directly import Java operations such as Java Selenium WebDriver to create automatically the required scripts. You also have a scripting module that we will detail later in this training. The test-on module allows to generate .sec files containing test-on binary parts or some LabVIEW, CVI, DLL, .NET, ActiveX by setting or by measurement, but also some sequence files which are handled in test-stand. You can have a look to the dedicated test-stand tutorial for deeper information. You can also generate UFT formats either directly in your ALM or by importing QFL or Visual Basic files to create these test scripts. Let's do some custom scripting with a scripting module in which you can create your own state platform. Rename the platform into scripting CC, and thanks to the scripting, you can generate several output files. Click on Scripting CC and go to Output File, where output files will be recorded. Create a file that will be linked by default to all future operations. Call it script CC extension .txt. A simple example for this training: choose the UFT8 format to handle language traces. Then you can link several operations to this scripting file. The goal of this operation is to match them into your model, and each time MaTeLo is passing by a transition containing an operation that you are going to create here, it records the scripting part linked to the operation and its relative parameters. Create an operation, which will be a command used to set a signal to a specific value. You can call it setSignal with two parameters, the signal name and its value. You can create as many parameters as you need. The setSignal keyword that you just created, you are going to link it to a script file. You can import in script file path, or you can create it. You can create it in a specific path, but let's record it directly into MaTeLo project folder. To do it, copy the project path, select setSignal, and its script file path indicates the file which is linked to it in cruise control folder. create a subfolder to gather all scripting operations that you are going to use, for example, scripting templates. Create a file to link to this operation, setSignal.txt. Edit this new file and write the scripting part that you wish to perform when you call this operation. Call it setSignal, but of course the language depends of your test bench or what you want to create. Open a parenthesis and call the signal parameter, which is located in setSignal, pressing on Ctrl space with your keyboard. When you press Ctrl plus space, you have access to all model and MaTeLo data. It is used to get transition names, requirements names, parameters names, and so on. Choose $signal that you could also have directly written with the keyboard. For this training, you can invent a scripting format. Let's write a semicolon and add its value, entering it manually. So, $value, and you can see that it automatically appears in red as soon as the word is consistent with the parameter name. Close the parentheses and add a semicolon. As you have created an operation, don't forget to save the project so it is working. Then, link this signal where you need in the model. Go back to root and set a signal if you select a vehicle with manual gears. In the Test Platform tab, drag and drop the set signal operation and complete its parameters. Write them in fixed values, but you could use a list containing all signals. Enter manually the signal and get back the value that MaTeLo has chosen in the enumerated. So, take directly the value from the transition. You could get other information such as the test case name, but here, what you want is transition input and item value. For enumerated, which are types, you have a list with elements which got a name and a relative value. Item value gets the value from this column, while item's name gets the name reference. So let's choose the name, manual or automatic. If you wanted the value 0 or 1, you could have chosen them here. You can also use alphanumeric values in this column. Do the same on the other side. Drag and drop the set signal operation here. Choose transition input and item name, then for Start Engine. You are going to do that for part of the model. Call the signal engine and set it fixed value, for example on. Add a speed that you can call speed, and for transition input, the speed value. If you don't want to manually choose these values, you can create as many signals as you want. You could define the set speed signals or others, it would be quicker. When it is industrialized on real projects, there are usually many signals to avoid filling them with fixed value. Here, change the speed selecting transition input to get the speed value at this level. Working on the speed, do the same here. Speed transition input value. So it will always use the speed which is defined by MaTeLo through equivalence classes. I made a small mistake here, you should manually write speed. Then stop the vehicle. For the speed, you could directly use the value 0, but choose the value from the transition. For enable CC, you also have to fill in the information. Write enable and for its value on. Then go to this macro chain for raise transition. Write raise and on. Define another speed change. You could have created a dedicated operation for speed change. So it will automatically link it to the variable to not always fill it manually. Just to show you, here you could have used Ctrl plus space and link it to $input bracket speed value to directly get this value. You won't use it in this training, but it's good to know it. Then press on cruise control button and let's say it is set the value that you use. And if you press it again, it is also set, as it is the same button. So CC and set. Here you push on cancel, use the name cancel and set for its value. You can also link scripting operations on conditional transitions, no problem. So clutch and set. Neutral. And set. Break. And set. We don't do it everywhere on this model, but it is to understand how it works. You should also create a get signal operation to check the current speed value and set it everywhere in the model like you did. You should create and link these operations everywhere in the model, but we don't do it now. Generate again several test suites with a user-oriented plus filter algorithm with a filter on transitions. You obtained 3 test suites with 2 of them which are quite long. Add them to the project. They are recorded in the Project Explorer. Export them in test script with a right click, export test suite to script. You can see them already ticked. Save them in the repository and copy its path for later. You can see here your test platform and you can have as many as you want. You want a test script for each test suite. Click on Finish. Test scripts are generated. It is very quick. Let's check how it looks like. You got several generated files. a full test suite file, which is a MaTeLo format containing all data from the test suite. It is an internal XML MaTeLo format which can also be used with small external tools that you create, with the aim of not having to create some scripting operation, which means that you can transform this file into another format using XML transformation operation. But for this training you already implemented the scripting to automatically generate the format that you wish. Open the file which has the same name and you can see the different signals which are called for this test suite. TS automatic set minus, the automation is not finished, but you can already see the operations that you used. At the moment there is only one operation, but if there were several, you could see the relative code or keywords. You can also add other information in this file. For example, you could define a header either for this test suite or for the whole group of test suites. If you want to create a header for each generated test suite, create a new operation that you can name header test suite. Link it to a test script that you can name header test script or ts.txt. You don't need parameters. Edit it and define its formats such as test suite, and clicking on Ctrl plus space, choose $testsuite.name. You could also add the name of the algorithm which is used or any other generation data. Don't link this header directly in the model. You are going to link it directly to the scripting platform. To open the scripting configuration, click again on the small icon at the bottom. And after clicking on Others, open the Test Platform configuration windows. Move it to a more convenient place, and you can now link operations to specific parts of the test platform. Either by test suites, which means a group of test suites concatenated in only one, or you can link this header for each single test suite. You can also add a footer. To brighten up the test suites, you can also display the transition name, which is automatically written for each tested transition. Create a new test operation and name it comment. Link it to a script file, clicking here, and you can call it comment.txt. Edit this operation and add a description with a step number. So, number, Ctrl plus space, and look for $step.number. Then you can add the transition name, so $transition.name. You could also display the requirements. Link this operation at the header level of each transition. You can also add a header at the test suite level, which is again a concatenation of test suites one after the others. Create a new operation header TS and link it to a test script file here. Create the script with what you want. Test suite and the profile name, for example. The profile is this information, the default profile that it can display. Set it at the header level, but you could also define this information for the footer. Generate some test suites with a user-oriented algorithm. You can choose to generate 100. A big number to show you the performance. You got test suites which are all different sizes and automatic naming. Add them to the project. It is mandatory if you want to export them. If some already exist, replace them. Export these test suites into test scripts with a right click. Save them at the same location. This time, choose to make only one big file with a concatenation of all test suites. So, it is generating a big file with all project scripts and all relative XML files. It is done. Let's check the outcome. It is this 576 kilooctet file which contains all the data. You can see the test suites header. Then for each test suite composed of test cases, you have the test steps. There is a ETF8 problem which should be fixed in an output file configuration. You can see for each test step the transition names and signals that are sent to your test bench. You can see in this file all test suites one after another and their relative information. It is you who decide and create the required script language, and it can be adapted for any format. You could also create .csv files with a semicolon or colon or XML, bash commands, DOS, Unix, anything you want. You got a 14,000 lines in this file. The automation is not finished in your model, but it is your job to do it. It is just to explain how the scripting works. If you have any question, feel free to ask them directly in the video comments. To be notified of our future MaTeLo videos, please like this video and subscribe to MaTeLo channel. Don't hesitate to connect, follow me on LinkedIn.